Hello everyone, and welcome back to another Eng 130 video tutorial. As always, my name is Clayton, and I'll be the one guiding you through this tutorial today. So the tutorial today, it was hard to think of a title, so I just put starting with resultant force, but basically it'll be a little similar to the last example where instead of given all the initial conditions, we start off with some of the final conditions and we can work our way back to find the answer. But this one has a little bit of a trick to it, and this trick it's very useful for this example, of course, because you're going to need it, but you can see this later on, and this trick is something that you guys, in my opinion, should really know, because when I did help desk a couple of years ago, there was an online question that had this trick to it, and boy, it caused students a lot of problems. So I put this in here basically just for this trick, but the rest of the problem doesn't hurt too. So with that said, let's get started. Alrighty, so looking at this example, it says it wants us to determine the magnitude and direction theta of FA so that the resultant force is directed along the positive x-axis and has a magnitude of 1250. So again, as I was saying, instead of finding resultant force in this one, we're going to have the resultant force and slowly work our way back. So from the last example, you guys know these type of questions. You can use the parallelogram method or you can use Cartesian vector notation, but I'm going to be a little bit mean today, and I'm just going to use Cartesian vector notation. And the reason why I'm just going to use that is because even though you can use both, Cartesian vector notation is where it's at. It's where you guys need to practice because it will stay with you the whole course and into your future engineering careers. The parallelogram method, I'll be completely honest with you guys, I don't think you guys will see it ever again. It's nice to know, but actually there's a funny story. When I was graduating, as a joke, they gave us a quiz from Eng 130. So this is like you're graduating, all the students are graduating, we're given this quiz, and it had a question on the parallelogram method, and it was just a joke because not a single person remembered the parallelogram method. So I think we all failed that quiz, but nevertheless, it's nice to know. But Cartesian vector notation, it's where it's at. All right, so let's look at what we know here. So what I like to do for these type of questions is when they give you a nice, fancy, colorful picture, to me, I get lost in all the details. So what I like to do is I just like to make my own diagram so I know exactly what's going on. So I'm going to start by drawing my x and y axis. Ta-da! I can do such nice lines with this iPad. All right, so we know that this is going to be x, this is going to be y, and we have two vectors. So as always, I'll color code the vectors. FA will have as red, and it'll come up like this. So on here, we're going to go up. Ta-da! It's going to be FA. So again, we should label the vectors. We don't know what this is, so I'm just going to put F sub A. And then the second vector, we got FB, and this one we know, so it's a little bit nicer. Oh, I'm not going to put it as that color, or else you won't be able to see anything. We'll go back to blue. So this will be FB. Again, just make it nice so you guys know which one I'm talking about later on. And it's going to come down something like this. So what's nice about FB is we know it's 800 newtons. So down here at the bottom, I'm just going to put 800 newtons. And what I'm also going to do real quick, and even though I'm not going to put it on this diagram because I don't want it confusing people thinking it's parallelogram method, we also have the resultant force. And we know the one thing that it says is the resultant force is going to be directed along the positive x-axis. So we know that the resultant force is going to just go like this. And it says we want it to have a magnitude of 1250 newtons. 1250 newtons. And then finally, what I like to do is I like just to throw all the geometry in so I don't get confused. We know that this angle here, 30 degrees. We know that this angle here is just going to be theta. And that's it. And frankly, this is all you guys need to solve the question. So I'm just going to relate to this diagram to move on. So Cartesian vector notation. Let's just remind ourselves what it is. Basically, what we're going to do is we're going to split both of our initial forces into x and y components. And then with those components, we can add them together to get the components of the resultant force. And with the components of the resultant force, we can then find its magnitude, direction, and stuff like that. All right, so, well, where to begin? Let's start with finding the components of each. So let's start with FA. So I'm just going to go to red. Let's go FA. FA, so we know that FAX right here is going to be, and this is our variable, FA, so because we don't know what FA is. And we also know that the x components are going to be times sine, and we don't know the angle either, so sine theta. So not off to the best start. We don't know either of those. However, that is the component of it, if you will. So FAY, just as awfully, is going to be equal to FA, we don't know, times cosine of theta. So ta-da, we've literally done nothing. We have no values yet, so nothing. So the next thing we can do is we can then move on to FB. So FB here, FB, we can know that FBX, so the x component, is going to be 800 times the cosine of 30 degrees. And FBY is going to be equal to, sorry, I had to clear my throat, 800 times the sine of 30 degrees. All right, so that looks a little bit better. We can actually put values in there. Those are actual numbers, so things are picking up. So here's the trick to this question. Well, actually, no, I'm not going to say that. The trick I want to show you guys is coming later, but the methodology to solve this question comes in this. We know that for our resultant force, so I'm going to go back to green. Actually, no, I'm just going to, I think I can do the rest in black. All right, so we know that for the resultant force, we know that the x component of the resultant force is going to be equal to the x component of FA, so FAX, plus the x component of FB, so FBX. And we also know that FRY, so the y component of the resultant force, is going to be equal to FAY plus FBY. So this is kind of nice. And what's nice, if you, well, you guys will see this a lot, is you'll start to think of x equation, x unknowns. And what that basically means is if we have, let's say, 3 unknowns, we're going to need 3 equations. And this will come a lot later. You guys will hear that a million times. You'll never forget it. But what's nice here is we know we have 2 unknowns, but right here we have 2 equations. So this tells us that we can actually start to solve things. So let's sub in values to these equations, and let's just kind of see what happens. So, I'm going to color code the equations to make them a little bit easier. So I'm going to go ... 1. So it's going to be equation 1. So if I say equation 1, you guys know which one I'm referring to. Oh, I don't want to go red. Let's go pink. ... 2. Equation 2. So now if I say equation 1 or equation 2, you guys know which one I'm referring to. So let's start with equation 1. We know that FRX, so the x component of FR, well, that's just going to be 1250. That's nice and easy. 1250 is going to be equal to FAX, which we already said was FA times the sine of theta, plus FBX, which is going to be 800 times cosine of 30. So if we only had this equation, we would not be able to solve it because there's 2 unknowns there. There's many, many solutions, infinite number of solutions, you could say. So that's equation 1. So actually, I guess just label these again so you guys know. Equation 1. It's nice to kind of keep track, especially if you're just looking at this and not hearing my voice. So equation 2, we know that FRY is going to be 0 because it's only along the x-axis. So that's going to be 0. It's going to be equal to FAY, so FA. But this time it's times cosine of theta. So again, we know none of those parameters. And then we're going to add FBY, so plus 800 times the sine of 30 degrees. Perfect. So now we have 2 equations. we have two unknowns, we can begin to solve all of these things. So to solve, I'm going to start with equation 2. So from equation 2, and the reason why I'm starting with equation 2 is because one of the sides is 0. It's very easy to start rearranging everything if that's the case, and it's 0. Alright, so now looking at equation 2, we know that the resultant force, the y component, is 0, so it's nice, it's just 0. And that's going to be equal to, and if we look up, it's going to be Fay, so Fa, which is equal to Fa times cosine of theta. And then it's going to be equal to, and then you add, and then 800, so Fby, 800 times the sine of 30. So here is where students will start getting mixed up. This is actually wrong, this equation 2. And all the values are right. We put Fax, Fay, and it's fine. But up here, you have to remember about the components. So Fby is actually going downwards. This is Fby right here. So that's why it helps to draw. So Fby right here is actually negative. Oops. So don't forget to check the directions. It's very, very important. And I was hoping that some of you would see that kind of partway through to know that that is negative. Because if you don't have it as a negative, you're going to get the wrong answer. So now we have two equations. And from these two equations, we can start beginning the process of turning it into one equation, which is not that hard of a process. I know you guys already know what to do. So what I'm going to do is I'm going to start with equation 2. So I'm going to go equation 2, put a little arrow sign, and I'm just going to rearrange it to isolate one of the variables. And I'm going to isolate Fa. So Fa is going to be equal to 800 times sine 30. So I just moved the 800 sine 30 to the other side. And of course we have to divide by cosine of theta. Perfect, and I'm just going to underline that because we're dividing all of it together, and ta-da. So now this is our new equation 2. And then what we're going to do is we're going to take equation 2, and what we're going to do is we're going to sub that in to equation 1. Because what happens now is we take away Fa completely. So our equation will only be in terms of theta. So once we do that, we're going to get this equation up here. We're going to get 800 times sine of 30. And that's all divided by the cosine of theta. So this is just Fa right there, the first part of equation 1. And then we all know this is going to be times sine of theta, because it's Fa times sine theta in equation 1. So then we go plus 800 times cosine of 30. And we know that all of this is equal to 1250. So what's nice about this equation is we only have one unknown now. And I'm just going to put the divided sign right here. But this is the trick. And this right here is basically why I picked this example. So if you aren't listening, now I suggest you listen. It's solving for this when we have cosine and sine. If these were all cosines of theta, it's perfect because we can easily just go cosine of theta. But it's hard with sine and cosine of theta because the sine of theta is not going to be equal to the cosine of theta if theta, of course, is one value, which is difficult to solve. And this is what happened last, I think 2 years ago, when there was a question like this. The students didn't know where to go from here. They'd come to here, And they get to this part, which is great, but then they just get stuck. So this is where another, and I know you guys are going to start hating this, but another trig proof comes into play. And that right here is this. And the reason why I'm highlighting this is because it's a very common one to have this. It's this right here. Check if you have cosine theta divided by sine theta. Because if you have if you have sine theta divided by cosine theta, which we do in this case, that's actually equal to the tangent of theta. So if we were to sub tangent of theta into this, what we'll get in the end is 800 times sine of 30 plus, oh, sorry. I forgot a little part. I forgot the part I wanted to show you. Times the tangent of theta plus 800 times cosine of 30 is equal to 1250. So now we look at the equation. We only have one unknown term, and that right there is the tangent of theta. So then what we can do is we can start arranging everything. So we're going to get the tangent of theta is going to be equal to the 1250 minus the 800 times cosine of 30. So I just moved the 800 times cosine 30 to the other side, and we have to divide all of it. So that's another common mistake students make, is they only divide one term of this, but it's both parts. We have to divide by 800 times the sine of 30. So the trick right here has to be the whole thing divided by it. A lot of students will just put that just one. So once we get that value, we can inverse tangent it, and we'll get a theta is equal to 54.3 degrees. Oops, went back to there. I'm getting a little bit better with not going to the eraser, but not the best. And that's the final answer, so we're just going to throw a box. A box. I did my air quotations there. A box. That's nothing like a box. We're going to draw a box around it. No, it's not being nice to me today. Come on, let's do this one more time. Close enough because I can do that. All right, perfect. So we know that our theta is going to be 54.3 degrees. However, remember, this is not the final part of the question. The question also wants us for the magnitude. So right here, the magnitude of it. That's already easy because if we look up here in our new equation 2, we have an equation for FA that's based on if we know theta. So I'm just going to go to here and I'm going to put 2. From equation 2, we know that FA is equal to, and we'll scroll up to check, 800 times sine of 30 times the sine of 30 divided by cosine of theta. So we know theta, this will be the cosine of 54.3 degrees. And what you'll end up with is FA, I'm going to go down one, it's final answer, make it very clear. FA is equal to 686 newtons. Remember, final answer, we want to put those units on it. Perfect. So that right there, and then I'm also need to put the divide sign across here. Perfect. So that's the question. We have our FA, the magnitude, and we have the angle that it acts at. So this is the completion of this question. Again, the trick I wanted to show you guys, the trick I was talking about at the beginning, was that sine divided by cosine. If you're ever stuck with that, remember you can somehow change it into tangent. So if it was cosine divided by sine, you can change it to 1 over tangent. And that's the easy way to get rid of the combination of sine and cosine. And again, I'm just going to highlight this so you guys remember it too, because this is also nice to know, is you have to check these directions so that since the y was going down, we needed a negative there. Have to check that, because without that, our answer would be completely different. All right, guys, so thank you all for listening, and I will see you guys in the next tutorial.